All, welcome to CAE Bootcamp. Today we are in our module 2. Yesterday in the last class we have learnt about the module 1. In the module 1 discussion about the Altair, and we have discussed about the FEM and FEA and introduction to HyperMesh. How to manage with the files. We learned all these things in the module 1. In continuation to the module 1, today we are going to build the 2D modeling. Like what is 2D modeling, how it looks, and what are the requirements to do the 2D meshing. See, for example, as soon as you received any CAD, whether to go for 2D or 3D mesh, these things we'll discuss in the today's session. Along with that, we are going to create the elements on the extracted mid surface. Then we are doing any mesh corrections if it requires any mesh corrections, and quality for those things we are going to discuss one by one. The image what you are seeing in this, the first image is for the CAD file or the CAD model, the geometry, CAD. This is a complete volume CAD. And the second one image is the finite element model. See, for the same component, for the same CAD, we have extracted the mid surface. Then on top of the mid surface, we have created the elements. After creating the elements, the component look like this. The image in the second image, what you are seeing, this is how the model look like after completing the mesh. Okay, this is the agenda for today's session. We are going to start with editing the geometry. That editing section, like in the previous model, that is in the module 1, we have discussed what is editing the geometry. Say, for example, when the geometry is unconnected, when the geometry having any triple bonds, or if the geometry having any untoggled surfaces, if stitching is missing, or any other things, these things we are going to carry in the geometry editing. Then next comes to the introduction to meshing. In the meshing, what we need to do? Okay, you have extracted the mid surface, you need to start the meshing. But before starting the meshing, after extracting the mid surface, there are certain work to be done for the extracted mid surface. We learn one by one. Then after all, what are the elements which are available in HyperMesh? See, randomly, if you want to tell means, we can create any shape of element starting from the triangular element. Even joining between the two nodes that become in line. When the joining become the three nodes, that will become a triangle. So likewise, we can go for the pentagon, hexagon, nanogon. So like that we can go. But when we are considered to do the 2D meshing, what are the elements are available in the HyperMesh? We'll check all those things. Then we'll do the mesh addition. See, generally, the software will give you an auto mesh. The software will give you auto mesh. There in the auto mesh, there is no manual work. Just by going and clicking the surface, then the mesh will get creating. But mesh addition comes to the requirement of my project, or requirement of my for the requirement of the component, I am going to edit the mesh. Then the quality. See, after creating anything, we need to certify it, like using in certain parameters. I am going to finalize that element. Then finally the thickness assignment. We'll discuss one by one in HyperMesh. Okay. See, I hope you have also received the same CAD file. This is how the geometry looks. See, when you click on the keyboard button D, it will show some of the files. Like it is for the geometry page. You can see in the right side, there is a geometry tab. This is for the geometry. If you click on it once again, it will ask you the elements. First, we will receive the CAD. On that CAD, we are going to create the elements. So I just go for the display button D. It will display all the elements and the geometry, what it is having. See, this is how the component is. I hope you also received the same CAD file. And we know how to rotate the file and how we can pan or how we can move within the GUI of HyperMesh. The same model information is available in the left side of this one. That is in the model tree also it is available. Here you can see the component name tabular 1_body. This is the name of the component. The 3 number mentioning, this is the component ID. Then it is the color of this component. You can change the color either here or and go for Shift F1. There also you can change the color. Go for functional key Shift F1. Select the component. Choose the color. Then it comes to, as I said, this flag symbol is denoting the geometry. Here elements are not there. We need to create the elements for this. Then if you want to add or any deleting the component, it can be done in this section only. Our first thing is we need to review the CAD. Here it is in the part. I'm going to keep it in a component view. Either you can view it in a component, property, mat, or these are the available option which you can visualize the component. I want to visualize this component by components or by collectors. Here I'm keeping in a mixed mode. Now it is in the auto mode. Now I'm moving to the mixed mode. In the mixed mode, what is the useful of keeping in the mixed mode means it will distinguish between the unconnected or any supporting lines or any free edges. Those things we can visualize by keeping it in a mixed mode. See, keep the geometry in a wireframe. Once you keep the geometry in a wireframe, just visualize the component. See, just visualize the component. We are not able to see any red lines. It means the component is, now the component is doesn't having any, it doesn't require any geometry corrections. I'll just delete one surface, keep it in a wireframe again. See, now you can see there is a red line. It means it is a free edge. Either it is a free edge or it is a missing surface. So these things to be taken care before you extract in the mid surface. As I said, in the model 2, I'm going to do the 2D meshing. But you can ask me why we need to do the 2D meshing only. Why not the 3D or why not the 1D element? See, for 2D element means you can see the thickness of this component. By looking at the component only, we can decide whether we can go with the 1D or 2D or 3D. I can tell this component I'm going with 2D meshing. Why? Because I can define the thickness. See, the thickness of this component is very less. It is 3 mm thickness. When the thickness is between the certain range, for example, if it is the thickness is in between the 10 or 12 mm, we are going to extract the mid surface. The number which I am denoting or I'm mentioning here, it is just for an example. It is not okay specifically, it is meant for 10 mm only. It is not like that. For an example, I'm telling, if we can extract the mid surface, then we can go with the 2D meshing. Just assume we have seen the engine component or any casting component. It looked like one solid thing. For that, I may not able to extract the mid surface. So for those kind of components, we are going to do with the 3D meshing. When we can able to extract the mid surface and when my component look like this. So for example, when it is having the ribs, you can see these are the ribs. This is in square rib. See, either it is in square rib or it may be a triangular rib. Here I can see some of the square ribs. These ribs, most of the cases, these rib will come for the thickness component. And these rib, when these ribs are there, we can go with the 2D meshing. So this is the basic thing we should know why we are going to do the 2D meshing. Why we are going to do the 2D meshing means when we can extract the mid surface, then we can go by choosing the 2D elements. Now we'll start extracting the mid surface. The mid surface option is available in the geometry page. You can see in the geometry page, go for mid surface. And in this drop down, keep it as an auto mid surface. In the second one, extraction option is there. Here, there are the 3 other different options are there, which is very useful for extracting the mid surface. I'll go with the offset, plane, with sweeps I'm going. Just click on the, just come to here and set it for the offset plane. Go for extraction option. Just click on the surface. In a single click, complete component should get selected like this. In a single click, it should get select like this. Then come to the extract button. If you click on this extract button, please observe in the status bar. In the left corner of the HyperMesh, observe the status bar. In the status bar, it will show how much percentage is completed. Okay, how much percentage is completed by extracting the mid surface. How to extract the mid surface? In the geometry page, mid surface panel, inside this sub panel, extraction option, I am keeping offset, plane plus sweep, I am keeping. Go for the auto extraction, select the component and say extract. Observe in the status bar, say extract. See, it is showing 58% is completed and 75% is completed. These HyperMesh, how it will work? No, first it requires a good RAM speed and the graphics card also. Based on these things, your component will work. Okay, the mid surface is extracted. See, in between these two, you can see one red line. You can see the red line all the way. See, now the earlier my component is in complete volume surface. In between these, I can able to see one more surface. We'll visualize only the mid surface. Just untick this one. See, this is the mid surface. This is how the mid surface looks like. As the name indicates, mid surface. In between the two main surfaces, we will get one more surface that is called the mid surface. In between the two main surfaces, see, you can able to see. This is how the mid surface looks. And here only we can see the thickness. In the same geometry panel, mid surface extraction, go for review thickness. Okay, this is the thickness. Just click on this surface and see. This is a 5 mm thickness. Come here, it is a 3 mm thickness. In a single component, we can see the variable thicknesses. Variable thickness means take any automobile example, take any automotive part, any of the car component. All the component will not be the same design. All the component will not be the same dimension, same material. Everything defines its own unique design, material, property, thickness. All these things will vary from component to component, from design to design. It will vary. So likewise, in the same component or else in the same part of the automobile, in the easiest way, if you want me to tell, in the same part of the automobile, there is a variable thickness. So like this, see here in this flat surface, I can see the 3 mm, whereas in the rib section, I can see the 5 mm of thickness. So this is how we are going to review the thickness. Now what we have done, we have extracted the mid surface by using offset, plane plus sweep I have used. But here, if I switch on my original CAD, increase the transparency, say my component is not breaking anywhere, whereas my mid surface is not completed. Here, the surface is missing. It means the first option which I have used, that is offset, plane plus sweep, it is not working to the extent. So what I'm going to do, I'm directly deleting this mid surface. Say delete, or else go for F2, select the component, go for F2, select the component here, and you can delete it. But I have deleted directly here. Now switch on the CAD again. See, this is the original CAD. I am going back to mid surface. This time I am keeping offset. See, this time I am keeping offset. Come back to auto extraction. Click on the surface. Say extract. So it will take 1 or 2 seconds to get extract, and this is based on your system configuration. Okay, the mid surface is ready now. Switch off the original CAD and see the component. Okay, now I got a better mid surface compared to the first one. See, this is an advantage by using an HyperMesh. That is, there are 3 options are there. You can use anyone based on the component. See, for some component, the offset will work very good. For some more component, if it is having any curved features like this, so like this, any curved features, no, for those component, the sweep option will work very good compared to offset. Now we have extracted the mid surface. Now again, I'm switching on the original CAD just to see where and all the CAD is missing. Okay, CAD is connected here, but still we need to work on the things. Okay, switch on only the mid surface. We have learned that before extracting the mid surface also, we need to correct the geometry. Why? Because to get a good surface. Again, after extracting the mid surface also, I need to correct the geometry. What are the things to be correct? How to correct? I'll show you. See, just you come here. I'm just zooming in this area. Keep it in a wireframe. See how the distracted surface is there. This is not the surface which I want. See, you can see it anywhere. Surface is very bad here. So if I create a mesh on this, just observe. I'm just create one temporary collector, ABC. Say created it. The same component will appear here. Go for F12. I'm just showing this one. How the mesh you will get. Okay, see how the mesh is. This is a very bad mesh. So to avoid these things, we need to correct the geometry before creating any elements. How to correct this one? I'll show. I'm going back to the delete panel, switch to the surface. The delete panel is available in the F2 button. Go for the F2, switch on the surface, switch to the surface, select the surface and delete it. See, the surface is deleted. So here also I'm deleting the surface. We keep it in a wireframe and neatly observe this one. I need to delete this also. Okay. Okay, we have deleted these things. Say delete entity. See, again, this rib is going. So I need this rib. Okay, here also I'm deleting this one. Choose this one. Okay, delete entity. So like this, you need to do for all the ribs you need to do. Now the same will apply here also. Select the surface and delete entity. Keep it in a wireframe and observe the CAD. Okay, here the geometry is very bad. You can see by looking at the CAD only you can decide. Anyway, the CAD design will not be like this. In any automotive part or any part, the CAD design will not be like this. So delete entity. We are not requiring those things. So like this, you need to correct all the way. We'll move to the next CAD correction. See here in my original CAD, it is connected. See, it is connected completely. You can observe it is connected completely. Whereas in my mid surface, it is not connected. So how to connect that one? Go for the points. It is available in the periphery icons of the HyperMesh. See, go for this periphery icons. Switch on the points. See, the points are appearing. Now, I'll go for the topology correction that we have learned in the module 1. Go for the quick edit and this replacing the node. Go for the replace point. Keep it in a wireframe. Select this one and replace to here. See, now I have corrected this one. Then again, I'll go for the toggle edge. I'll try to stitch this one. If not, okay, not an issue. Then we'll move to the different place. See, I'm replacing this node to here and this to this I'm replacing. So like this, you need to correct the geometry. So here also we need to correct it. Why I'm correcting all these geometry means I need good flow of elements. Here also it is not connected. So what we can do, select the node and place it in the required place. Okay, this is how we need to correct it. And see here the plane is not good. As usual, we need to go for the F2. We need to go for the surface creation and we need to correct these things. Here also, here and all, it is not connected. So what we can do, closely visualize the CAD and start placing the things. Here, the surface is not edited. How to edit the surface means go for the surface edit. Okay. Now choose this one and choose the line. Say trim. It means trimming means I'm just splitting this geometry. I'm just splitting this surface. So how I am splitting? See, now I have made it for the two sections. You can see. Now you can see the two surfaces. One is here and one is here. How I did means along this line, along this red line. See, along this line, I have just splitted the surface. So like this, you need to correct all the way where and all the CAD is not good. This comes to the CAD correction part. The one more thing is, here in this component, we can see there are some circles are there. See, there are 5 circles are there. The basic reason for keeping a circle is either it is a normal circle or that circle is representing some bolts. It represents some bolts or nut it is representing. All the component, all see every time I'm taking the example of car component only. Why? Because so that you guys can imagine yourself. See, for example, I'm telling one component is coming means it is going to fix or it is going to adjust with the one more component. How we can adjust? By either by welding or by giving the or by connecting with the nuts or the bolts. So like this, we are going to connect it. To connect to either to go, if I am going to connect my component using an bolts means obviously I need the circles. These things we have studied in your academic part also. Likewise, here the circles is coming means either it is a normal circle in the sense there is some design. So the component having some design for that valid reason. If not the normal circle, it is a bolt hole. So how to represent the bolt hole means by taking or by creating one washer to the circle. See like this, go for the quick edit. Here the washer diameter, choose the washer diameter, just click on this line. See like this, you need to create a washers. Why washer I'm creating means to represent this bolt hole. If you want to increase the diameter of this washer means just you can set the number, whichever the number is required. Click on the circle, the washer will get create automatically. See, the washer will get create automatically. So like this, you need to create a washer to represent the circles. To represent the circles, we need to create a washers. These are the basic mandatory checks we need to do before we are extracting the mid surface, before we extract the mid surface. See, the extraction option, we have learned where it is the extraction option and how to extract the mid surface, we have learned. Now we'll move on to the meshing. Now the CAD is ready, our geometry is ready, we have set for the washers, we have cleared the CAD, now we'll go for the meshing. Basically, what is meshing? As I said, the finite element isn't discretizing or dividing. Dividing, that is a basic thumb rule for the meshing. It means I am going to define or I am going to divide it into the equal number, Say for example, say I'm taking the circle example only this much portion. If I am dividing means I don't know how many points are there, but I know only the degrees of freedom. By using the degrees of freedom, I cannot define the equation. That means how many points that multiplied by the degrees of freedom for each node or for each point, that gives you the total equations, that gives the total equation. Here in the first image, I'm not able to define anything. For the same portion of the circle, I have taken it for the finite element analysis and I'm dividing with the 8 nodes. I have divided this portion with the 8 nodes. Along the, I'm giving the 6 degrees of freedom to it. With that, I'm giving 6 degrees of freedom. I know the number of nodes and I know the degrees of freedom. By using these two, I can define the total equations. See, here I have mentioned any continuous object has an infinite degrees of freedom and it is not possible to solve in this format. So any continuous means this object has infinite. I'm not able to give the solution to this one. So I'm taking this portion to the finite element analysis and I can extract the result to it. This is what we are doing in the meshing. Meshing means discretizing with the known number of points. Then comes to the elements. What are the basic element shapes which are available in the HyperMesh? See, generally we can create any shape of the element, but HyperMesh supports to create triangular element and quad element. That means this is a 3-corner element or 4-corner element. Again, this triad element is going to divide with the 2. That is the first order element or the second order element. The same, these things we have learned in our academic, saying linear triangular element or constant strain triangular element or parabolic element also we can call, or second order element also we can call. The second order elements means in between the corner node, there is an extra node in the middle. In between the corner node, there is an extra node in the middle of these 2 nodes. that is a parabolic element or linear element or second order element. These are the different name terminologies which we use in the industry. Likewise, for the quad also, either it is in 4-corner node or 8-noded element. These are the different two basic shape, triad shape or the quad shape, which are available to create a 2D elements. Okay, we know what is meshing and we have learned what are the basic element shapes which are available. Then we'll move to the auto meshing. What is an auto meshing? Auto meshing means go for the F12 option, click on the surface. The software will give you some kind of mesh based on this number, based on the element size. That is based on this size only, software is going to give the mesh. We'll see that. Just switch off the points. I have just switched off the points. Go for the F12 button. The F12 button is meant for meshing. See, this is the component. Here I'm keeping it to the surface. Here the element size I'm giving as a 5. I'm giving a 5 mm mesh. That means for this total overall component, for this complete component, all the elements which I'm going to create, all the elements will create more or less near the 5 mm only. Near the 5 mm only, it will work. Then in this drop down, we can see there are the different shapes are there. Different shapes in the sense, either you can use only the quad or you can use only the triad or mixed shape. One by one will go. First, I am choosing only the quad element. Just observe, I am using this surface, say mesh. You cannot see any triangular element. You cannot see any triangular element over here. See, you cannot see any triangular element over here. It means I have used only the quad elements. But the same thing, how it will work when I use only the equilateral triangles. This is the equilateral triangle. Same mesh. See, this is how the triad mesh looks. This is how the triad mesh looks. Say reject. But when I use the mixed mode option, mixed mode means it is a combination of triad elements and quad elements. So mesh, see, you can see there are some quad, there are few triangular elements and most of all quad elements. That means based on the geometry, software is going to give some auto mesh or the software mesh based on the geometry and along with the element size. The most of the cases for the CAE analysis, for the 2D meshing, we are using the mixed mode only. Generally, we are using the mixed mode only. But if any specific project requirement means, we can use the other kind of element. The other kind may be only quad, only triad, or only R trias. R trias means 90-degree trias. See, 90 degree. You cannot see any equilateral triangle. There is no 60-degree triad. All over the elements are occupied by 90-degree trias. But these specific R trias are only quads. These will be used only when the requirement or based on the requirement only we are going to use. But generally we are using mixed mode only. We are using. How to mesh this one? First, I am going to mesh this washer. Same mesh. See, here it is showing 25. Inside it is showing 19. When we are meshing for the washer, it should be equal number. See, the number which I am increasing here, you can see, you can increase any number you want. You can increase to any number just by clicking the left button. I'm not keeping any button on the, I'm not using my keyboard. I'm just using the mouse button just for increasing the left button. For decreasing, it is the right button. Say either by decreasing or increasing, you can create the elements. Say mesh. Here you can see the number 25 and 19. This is called the density of, this is the density, either by increase the density or by decrease the density. Or by doing the long press the mouse, the left button, you can fix to now, you can go for a higher order. See, inside the washer, it should be the equal number. It should not contain any triangular elements inside the washer. So you can, like this, you need to mesh for all the washers. See, like this. For increasing the left button and decreasing for the right button of the mouse. Here, it doesn't require any keyboard to increase or decrease the element density. Element density means here, just go and click on this one. Here, the number which you are able to see, this number is called the density. So like this, you need to measure. Then we'll take the some other surface, we'll mesh that one. See, earlier I have corrected its surface. Here I have not corrected. Just select this one and mesh. See how bad the mesh is. Here also the mesh elements are coming. This is not accepted. But whereas if I click on the surface and say mesh, see how mesh is. So this is how we need the mesh. This is how you need to measure. So mesh means like it is not just creating the elements, however the CAD is. No, that is having a set of procedures and a set of defined procedures. The element should create like this only. Like how I have created the elements inside the washer, no? Like this, you need to create the elements. So I'm selecting this rib and I'm meshing here. See how the ribs are, how the rib element is. So here again, I need to correct this one. Why? Because it is not exactly on this line. It is not exactly on this line. This is the manual, this is the auto mesh. This is called the auto mesh. Either you can go by selecting all the surfaces together, it will mesh. See, like this also you can mesh. But after selecting like this, we need to correct the mesh. The correcting mesh is called remeshing or the manual meshing, I can tell. So I'll show how to mesh some area. Specifically, I'll show how to mesh the required area. I'm choosing the surface, or else go for quick edit. I'm just splitting the line by using this node to here I'm splitting. Okay, like this I have split it. Then go for F12, choose the surface and mesh this one. See, now here 17 is there density, here 18 is there. So I'm decreasing to 17 just to have all the quad elements. In your the theory behind to keep the trias, number of trias means, so for example, if you are having the 100 element means you are allowable to keep only the 5 trias to overall 100 elements, or overall the component, you are allowable to keep only the 5% of triangular element, because using more triangular elements in any CAE analysis, it makes the components stiffer. So for this is the reason we are not going to keep that more triangular element unless it is really required to keep that one. Now we'll move on to this surface and we'll mesh this one. See, the triads are looking like this. I'm just trying by increasing or decreasing the density. See, you can observe I have just splitted one line and I got the mesh like this. But here I'm not splitting my geometry and I'm selecting directly and I'm meshing here. See the mesh difference. See the mesh difference, how it is. Now what we need to do, we need to correct it, or we need to remesh it, remesh this one. How to remesh this one? The same F12 panel, in the same F12 panel, switch to the elements, Now come and select the elements like this. Either by window also you can select, or by going one element also you can choose. I'm selecting using the window option. I'm selecting. Deselect all these things and say mesh. Here also it will work. I'm decreasing the density. Say mesh. See, this is how the mesh looks. And you can select these elements also, or by window also you can select, or by selecting the elements also, or else select a few elements, go back to elements again and take adjacent. See, like this also you can select. These are the different options are available to select the elements. I'll show only for this section how the mesh should be. I'm deselecting these things. Say mesh. Okay, now I'm decreasing one density here. Okay, mesh is coming like this. So come back here and choose the surface here. Choose this section and again ask for the mesh. Okay, the mesh coming like this. See, n number of time you can mesh it. Every time when you are going for the remesh, it will give you a new variety of new elements only. It will not be the same. It will not be the same. However, you have created in the last time. Every time when you are going on remeshing, every time it will give a different mesh. See, every time this is the fourth time I'm meshing here. You can observe every time I'm getting the new elements. So like this, you need to select wherever you want to decrease the number of dryers. To decrease the number of dryers, we are going for remeshing, or to have a better mesh flow. For that reason also, we need to go for the remeshing option. The remeshing option, why? Because means we to have a good flow of elements. So mesh. Okay, so like this, you can remesh the existing mesh. Okay? All these two dryers are gone. Say reject. See, now triangular elements are there. These are the back-to-back dryers. So mesh this one. So the elements are gone. Now go for the shift F12 just to smoothen the elements. See, observe how the elements are orienting. The all the way throughout the component, your mesh should like this. So by doing this one, you can create you can go by creating a good flow of elements along with the reduction in the triangular elements. We know how to do the manual mesh, and we know how to do the remeshing option also we have learned. Okay, we have learned these are the four different options which are available to create the elements. Now we'll move on to the quality parameters. What are the quality parameters which are required? I show, click on all the elements. Okay, I have completed the meshing for this component. You can see I have completed the component for this meshing. Okay, here after completing the meshing, what we need to do, we need to take care of the quality parameters. What are the major quality parameters which are required for the 2D meshing? The quality parameters are available in the functional key F10. Go for the F10 button. Here you need to keep for the 2D page. In the left side, it has mentioned the 2D page. In the 2D page, we need to check the main 2D quality parameters are warpage, aspect ratio, minimum length and maximum length, Jacobian, angles. This is the triangular minimum and the maximum angle for the tri elements, and the minimum and the maximum angle for the quad elements. These are the major quality check we need to do for the 2D elements. We'll check for the warpage. First, what is an warpage? Just I'll show. First, practically I'll show, then I'll explain. Click on the warpage. You can observe in the status bar, there are 10 elements are failing. It means out of this much, 15,667 elements are there. The overall component consists of around 50,000 elements. Around 15,000 elements are there. Out of these elements, 10 elements are failing for the 15 degree of warpage. Here, these numbers which I have mentioned here, these will change based on the projects and the requirements. Based on the project requirement and the component and the element size also, it will change. So, just click on the warpage. It will show 10 elements are failing. Say save failed. Go for F5. I'm just retrieving the elements. Say mask and reverse. Take the adjacent of the elements. Okay. Now, if I come back here again to F10, click on the warpage again. See, this element is failing. The elements out of these elements, these two elements are highlighting. It means these two elements are failing for the warpage. You click on any element, say it will show the warpage value. The warpage value is 15 degree. Basically, the definition of warpage is any one of the node out of these four nodes. Take the example of this element. This element I'm telling. Out of these four nodes, one of the node is not on that plane. So, which is that node we need to identify and we need to correct that one. How to correct that one means go back to F4, shift F4, choose the node. By looking at the node, you need to select that node and you need to select the plane. So translate and again go back to F12. Check this one. Now the warpage it is showing 13.28. It means we have reduced the warpage. We have corrected the warpage. Again click on the warpage. Now it was earlier it was showing 10. Now it is showing 8 elements. It means warpage means one of the node is not on the plane. So we need to select that node and we need to correct to the defined degree of freedom. Sorry, defined warpage degree. Then the important is aspect ratio. Here the aspect is showing 0 elements. The aspect means minimum to the maximum element length. I'll show you. Okay, you can see here. These are the elements which are failing for the aspect. Just see, it means you can observe the distance between these two nodes. Measure these two nodes, it is 4 mm it is, whereas the distance between these two is 0.72. It means the definition of aspect means minimum edge length to the maximum element edge length. So this is how the aspect definition. Next, the important thing is Jacobian. See here only the Jacobian example I can tell. Jacobian means how much the element is deviating, being in perfect shape. Perfect shape means that, see this, for this one you click on this one, see the Jacobian value for this one is 0.98. It means it is 100% matching. It is 100% ideal shape. Ideal shape means either it is a perfect quad element or perfect square element or rectangular element. When the element shape is like this, see this is not in perfect shape. Click on this element. Now see the Jacobian value. The Jacobian value is 15%. It is matching. So these elements will fail for the Jacobian. So basically the definition of Jacobian means how far the element is deviating, being from the perfect shape. This is the Jacobian, and the minimum and the maximum length. Now see, this is the minimum and the maximum length elements are failing. Why it is failing means, when we have used the 5 mm of mesh, for that 5 mm of mesh, we should having a 2 mm of element, that is a 2 mm minimum element length, and a 10 mm is the maximum element length. These things can be corrected using quality page also. This quality page is available in the 2D. Come for the 2D page. Here you can see the quality index. Click on the quality index. See, minimum size, aspect ratio, Jacobian, and these are the quad angles which are failing for the quality. Either you can go by translating or reflecting the notes, by translating the notes, adjusting the notes, by changing the angle, you can correct it manually. One more, the advantage is go for the quality index. Here you can just by placing the node, you can pass the quality. How to pass means, see the red element representing the dangerous element, which is failing for more degrees or which is failing for the more value. Whereas the yellow element represent, it is in a border line. It is in a border line that we can correct it. How to correct this one? See, just by dragging and dropping the node, you can correct this one. But after correcting the things, mesh should be very good. See, the flow should be very good. See, try to maintain the flow. This you can do it by going to the quality panel also, or else you can smooth these elements. To smooth these elements also, you can do it. See, by doing like this also, you can correct the things. This is how you need to correct the quality parameters. So this comes to the quality parameter section. Then the additional check in the sense, element should not carry any duplicate elements. Element should not having any free edges, and shed normals also we need to correct this one. I'll show you. See, when after completing the meshing, after correcting the quality parameters and all, we need to correct the shell normals also. How to correct that one means, go for Shift F10, select these elements and display. See, you can see there are two colors are there, red and the blue. But this is not a correct way of representing. How to correct this one means, either it should be completely red or completely blue. Say by face, say display and reverse. Now again, I will check all the elements. See, now I have corrected this. I have corrected for the red. Like this, you need to correct for all the elements. You need to correct for all the elements. You need to correct. See, I'm going elements by face. I'm taking. Say display and reverse it. Now again, I'm checking. Select this one and display. Now see, just I have corrected these things. Likewise, you need to correct for the other sides also. You need to correct and you need to check this one. And for the duplicate also, you need to check. How to check the duplicates? Here you go for the duplicates and you can check it. These are the major quality checks. These are the additional quality checks that we need to do for the 2D elements. Then we'll move to the next slide. That is how not to mesh. See, you can see here how not to mesh. Creating elements in the sense like, okay, however the auto mesh is giving, we are not supposed to do like that. See, this is the opposite trias. We are not supposed to keep the element like this. And these are the back-to-back trias. Just we have seen one example. The trias, we are not supposed to keep the trias like this. The flow should be the last image what you are looking. This is the recommended. This is the recommended flow of mesh. We should carry the elements like this only. But here you can see the true tria elements are sharing the single node. This is not allowed. These kind of mesh we are not supposed to keep. Then trias on the fillet region also we are not supposed to keep. And I said trias in the washer section or in the circular section also we are not supposed to keep any trias. And these zigzag flow of elements also we are not supposed to keep these kind of trias. See, these are the back-to-back trias. This is the opposite tria. This is a back-to-back trias. These kinds of trias are not allowed. How to correct means either you can go by doing the remeshing also, you can correct, or by changing the mesh also, you can correct. This is the recommended mesh which is required. See, now select these elements and mesh this one. See, this is the recommended thing. And see, here the tria which I have kept now, this is not the wrong representation. I need to change the orientation of this tria like this. I need to mention, I need to create it. And as I said here, you can go by smoothing the elements. See, smooth the elements, or else you can go, either you can go by remeshing this one. Say remeshing also, remeshing this one also you can go, or one more option, go for 2D quality index. By optimizing the elements also you can go. These are the different options to correct the mesh. Basically, like we have learned how to do the meshing, quality parameters, remeshing, and how not to mesh we have learned. And I hope the idea which I have given regarding the meshing section, that too for the 2D meshing, is very helpful for you guys. And I hope the things which we have discussed in this section is very useful. Thank you.